There should be 3 lanes. It should be 70 miles an hour. 75.
Okay. In order to find the maximum distance, what are we going to have to do? Find the derivative. Jake, what is the derivative?
Negative 32t.
And what did you do with that derivative? Set it equal to 0. And what was your time? Okay. How many of you did what Jake and his group did? Excellent. Then what did you do with 1.5?
Number line.
Okay, so to the left of 1.5 our velocity is? To the right of 1.5 our velocity is? Negative, so we have a maximum. Did you stop there?
Yes.
Austin, what do you have to do next? Okay, we actually have to figure out what that maximum distance is.
Oh, so you plug it back.
So when you plug it back in, what do you get?
28.
I have a 28, I have a 38. 28? I was going to try it in your calculator again. I don't know what's happening.
Ms. Holman, do you have to teach for the Holocaust speaker, or are you going to miss it?
I have to teach. I have senior class.
That's nice. You're missing out. Yeah. Some intel. Jake. Yeah, I lose on that round. This one? I lose on round 62 when all those hearts come in. Like
I'm on 50 times.
how do you beat the hearts? Okay, so this is a special mission. We'll get 5 towers.
Okay, so our max distance is 28. All right? Without having me tell you, you figured out that in order to find the maximum distance, you needed to take the derivative of position, find the critical points, right? Those critical points end up being where the velocity is 0, right? We change directions. If we change directions, our velocity is 0, okay? And so we have to look at that. Now, if I'm asking for a maximum distance from the origin, and you had a maximum and a minimum, is it automatically the maximum? No, because you could have a position to the left that's further away, and that would be your max distance. Does that make sense? Okay? Those are like robust. Yes.
Yes.
Okay. Let's talk about this one, maximum speed. Maximum speed on the interval. Okay, so first of all, maximum distance, you consider the position function. Even though it said distance, you considered the position, and then you found its derivative. So if I'm asking for maximum speed, what do we need to find critical, what equation do we need to think of to find its critical points? Okay, so our velocity function is negative 32t plus 48. We need to consider that and find its derivative's critical points. Okay, this is what we are trying to, we're trying to maximize the absolute value of it, which we'll get to in a little bit. But we want to find the maximum and minimums of the velocity so that we can figure out what the max speed is. Okay? So what is the derivative? Negative 32. Where is that equal to zero?
Nowhere.
It's not. Okay, so this is interesting because there are no critical points. Okay, so does that mean there is not a maximum speed?
No.
Okay, what does it mean?
Is it 2?
We're on an interval. When we find a maximum or a minimum on an interval, what do we have to do besides checking critical points?
Plug in the interval.
We also have to plug in the endpoint. So if we're talking about maximum speed, we want to know what the speed is at 1/2 and the speed at 2. Pods 1, 2, and 3, calculate the speed at 1/2. Pods 4 and 5, calculate the speed at 2. 1, 2, 3, go.
Negative 16. That's all down easy.
Yeah.
Like the absolute value.
All right, pods 1, 2, and 3. What's our speed at 1/2? 32. When you take the absolute value of the velocity, you get a positive 32. Pods 4 and 5. Velocity at or speed at 2. Excuse me.
16 negative. Well, it's an absolute value.
16.
Yes.
You guys got 16? 5, 4. Yeah. 16.
Don't be afraid. We're wrong.
So what is the maximum speed?
32.
32. Okay, let's take another flashback to physics. The rest of the day we're going to talk about free fall motion. What do I mean when I say free fall motion? Okay, we're talking about just dropping something, right? Or throwing something straight down, and we have the force of gravity affecting it. So, first of all, we're talking about a motion that is really just down, but we're going to talk about up and down motion instead of left and right. This is the only situation, free fall motion, where we will talk about position being up or down as opposed to left or right. Okay? It is possible to have no initial velocity. That would be me just like dropping something. Okay? This is 0 initial velocity. But if I threw it down because I was really angry, I would have initial velocity. Okay? I won't throw my pencil anymore though. In our calculus class, we are just going to assume that gravity is the only force acting, okay? And we're not going to take into account the size of the object, okay? Those are things that you get into with your physics class. Do you guys do that in physics, or is that like later in physics?
So we're not going to use air resistance?
Because we just do the most basic ones.
Okay. Fair enough. So,
Nice beginning.
here is our free fall motion equation. We're going to have, so this is our position equation. We first have to take into account our initial position. We have to take into account our initial velocity, and we have to take into account our force of gravity. Please write this down. You have seen this in Algebra 2, pre-calculus, physics, physical science, and now calculus. So this is not something that is new to you. Get some, thanks there, Jake,
Physics sense.
but you're about to,
Yeah, you're supposed to have.
okay. All right, now, this is where people who are really into physics, you're not going to appreciate me as much today. Sometimes we will have to use 9.8 meters per second squared, and sometimes we will have to use 32 feet per second squared. It depends on the situation. If you are given meters, you want to use 9.8. But if you are given something in feet, you are going to have to use 32. I'm sorry. Please take into account what the labels are so you can appropriately set up your equation. Now, if something is falling into the ground, then the gravity, it's pulling it in the negative direction, which is why we have a subtraction sign in our equation right here. That gravity is pulling in the negative direction. Okay, we're pulling down. Okay, so going back to this equation, if we were to find, so this is our position, right? If we were to find our velocity equation, we would take the derivative, correct?
Correct.
All right. Now, S naught, V naught, and G are all going to be constants that you put in. Okay? So if we take the derivative, what happens here? Okay, that goes to 0. The derivative of V naught times T would be V naught. And the derivative of negative 1/2 GT squared. Negative GT. Okay? And then if we want the acceleration, we would take the derivative of velocity. Well, what's the derivative of V naught minus GT? Remember, this is a constant, so its derivative is?
0.
The derivative of negative g times t is just negative g. This makes sense. Our acceleration is negative gravity. Okay? Our acceleration is the pull of gravity. Okay. So, what we are going to do today is we're going to work with the free fall equation to answer questions based on position, velocity, from not acceleration. Okay? Maybe we'll have to say maximum distance. Maybe we'll have to calculate some maximum speed. We'll see how it goes. Okay? But everything that we learned yesterday, we just need to apply to this equation here. So, first equation, write down some information. Okay, this isn't you specifically, Jake. Okay, so suppose Jake went outside and was actually able to throw a baseball up at a velocity of 100 feet per second. Okay? Michael, a 100 feet per second throwing a baseball. Is that pretty fast?
Yeah, we should change it into Michael.
Sort of. For Jake Carlson. That's pretty fast for Jake Carlson. Okay, how high will the ball go? Let's assume he's throwing it from 5 feet off the ground. Okay, when he releases the ball, it's 5 feet off the ground, which is probably reasonable for Jake, right? He's not...
That's 68 miles an hour.
68 miles per hour. So that's probably pretty fast to throw it up in the air. Okay, first thing we need to do is take this information and do what with it?
Write it down.
Okay. Since the ball is going up and then going down, we can use our free fall model. Okay? We're just having up and down motion. And so we need to take our position is the initial position plus initial velocity t minus 1/2 gt squared. Okay, what is the initial position of the baseball? 5. What is the initial velocity of the baseball?
100.
Positive 100, because he's throwing it, well, positive 100, okay? And then, what is the gravity we need to use?
Negative 9.8 meters per second. Oh, it's in feet.
So our position equation is 5 plus 100t minus 16t squared. We want to know how high will the ball go. What should be considered here? What's going to happen to the ball at the highest point? The velocity is going to be 0 and it's going to change directions. So let's find the velocity. Our velocity would be 100 minus 32t. So at that top height, our ball is going to change from positive velocity to negative velocity, which means that that instant is going to have to be 0, which is at what time?
3.125.
Thank you. At 3.125 seconds, our ball reaches its maximum height. Now, since, we don't necessarily have to make a sign chart for this, our position equation is what kind of an equation? Okay, it's a quadratic, it's a parabola. So we know it's only going to change directions once, right? So our position at 3.125 would be what? Isaac, what did you get?
161.25.
Okay. The ball will go 161.25 feet. That's a lot of feet for a baseball. Good job, Dave. The next question is, will he catch it when it comes back down?
Is that really a nice question?
What?
That's a nice question.
No. No. Okay. Now, you solved questions like this in Algebra 2, but you had to take this and you had to find the vertex by either completing the square or something and then figure out the max height. Isn't it so much nicer with calculus when you can just take the derivative and set it equal to 0? I think it's pretty great. All right, next question. A calculus textbook somehow finds itself on top of Papillion La Vista South High School. For unknown reasons, it falls off the side of the building. No one would ever do that with their book, right? Okay. How fast is the book falling after 2 seconds? I would like you to take a few seconds and talk to your pod about how you would go about solving this problem.
How tall is the school? You mean, 2,000 feet. What air resistance?
It is a book, books do,
Yeah.
yeah. We have no initial velocity.
Recent standard, you can get rid of. Initial height, we don't have one.
Yeah, I know we don't, we should have a
Shouldn't you give us a height or something?
Okay, so Cole is struggling with the fact that I didn't tell you how high the building was. Does it matter? It actually doesn't matter to answer this question. We can just say that our building is our height 0. Okay? And so we can set up our position equation. We can say, all right, we don't have an initial height. What's our initial velocity? 0. And so all we have is -1/2 gravity times t squared. If it gave us the initial height of the building, we could go ahead and throw that in. Now, here's the deal. It doesn't matter what the initial height of the building is because they're asking for how fast the book is falling. If we take the derivative, what happens to our initial position anyway? Let's do this. Let's write our equation as S naught minus 1/2 9.8 t squared. When we take the derivative, that initial position is going to go to 0, and our velocity equation is just going to be negative 9.8 times t. Okay? If we want how fast the book is falling, we want to plug in 2, but what else do we want to do with it? Okay, we'll want the absolute value. We know it's falling down, and so we're going to have negative velocity. I really only care about how fast that is. So when you plug in 2, and take the absolute value, what's our speed? 19.6. Since we use 9.8 as our gravity, what is our label for our velocity? Meters per second. Those of you in physics, you've worked with these equations before?
Yeah,
Did you relate them as derivatives?
no, we need to have like initial velocity, final velocity, just like kinetic equation, so we didn't take that to
He got mad at me when I tried to, so.
So does it make more sense, those of you in physics, now that we're talking about these as derivatives?
Yeah.
Okay. No? No, Isaac, you're not.
Oh, no, I wasn't talking about that.
Okay, how far has it fallen in only half a second? Okay, so if we stick with, calling the top of the building position 0, okay, we have negative 1/2 times 9.8 t squared. It's okay to think of the top of the building as position 0, because then when we go and say, all right, how far has it fallen after half of a second, we can plug 1/2 in for t and get what? It's going to be a negative. Jake, what do you have?
Negative 1.225.
Okay. Now, the position is negative because our book is now below the point of origin. Okay, we're basically calling the top of the building the origin. It's a negative position, which means we're now below it. Makes sense. The book is falling. Okay. So the book has fallen 1.225. What is our label? meters. Okay. So how far has it fallen in half of a second? We plugged in 1/2. How long would it take for the book to fall 50 meters? What do we do with the number 50? Okay, we set it equal to the position. Okay, how do we solve something like that? Okay, divide that number over and then take the square root of both sides. So go ahead and in your calculator do that for me.
So are we supposed to take
Oh, what did I do wrong? The 50 would have to be negative because it has fallen below our point of origin. So it would need to be a negative 50. Thank you. So how long would it take? Now, this one was nice because we only had negative 1/2 GT squared as our position. If our position equation had an initial position and an initial velocity, and we had to set that equal to a height, what would we have to use to solve it? Let me give you an example. Let's say our position equation was 5 plus 100t minus 32t squared. That was the one from before, right? And what if I said, okay, how long would it take for the ball to get 100 feet in the air? Okay, so you set this equal to 100. And in order to use the quadratic formula, you have to make sure it equals 0. But then yes, you would need to use the quadratic formula to solve for t. That's probably going to happen in your homework tonight. It will for sure happen in your homework tonight. So this is what I'd like to do.